Hi, I'm Tiffany. Today, I'm going to show you how to solve using order of operations.
Order of operations. When solving with order of operations, there's a few things that you want to keep in mind. First, you're always going to solve your problem from left to right. I'll show some examples to make sure that's understood. You want to follow the acronym PEMDAS to remember what order you're going to go in. The P stands for parentheses, the E stands for exponents, the M is multiplication, D division, A addition, and S subtraction. The M and D, or multiplication and division, are solved at the same time. The same is true for the A and the S, the addition and subtraction. They're also solved at the same time. I know that's kind of a lot to remember, but we're going to jump into some examples so all of this makes a little more sense. Let's get into example number 1. Example number 1. Before beginning, because I know I'm using our order of operations, I always tell my students to start by writing PEMDAS at the top of your paper. So I'm going to write it right up here. P E M D A S. My M and D, I always say it's a good idea to circle these, and my A and my S, it is a good idea to circle those, okay? You want to circle these two because just like in the last slide I explained, they work together. Now, if you remember, the first bullet point I made in the last slide was you solve your problem from left to right. So, what I do is look at each letter of my acronym and take my eye from left to right and determine if I have anything in the problem that is that letter. So, from left to right, I'm going to check to see if I have any parentheses. No, I don't. Exponents. I'm looking from left to right. Do I have any exponents? No, I don't. Multiplication and division. This time when I look, it doesn't matter if I see multiplication or division. It doesn't matter which comes first. I'm going to take note of it as I move from left to right. So I'm moving from left to right. Yes, I have multiplication. Okay. Because I have multiplication, that means I need to solve this part right now because that's the step that we're on. So to solve this, I say rewrite the entire problem except for the portion that you are solving. You're going to rewrite it as the solved answer. So this is going to look like 32. And you're going to subtract. The 32 was just brought down. The subtraction sign was just brought down. The 5 times 2 is actually solved in this step. And what is that going to be? It's going to be a 10. So you actually write it as a 10. You don't write the 5 times 2 again. So this entire problem was rewritten, except for the portion that we solved was written as whatever it ends up being. Do I have any multiplication or division left in my problem? No, I don't. So it's time to go to my next step. And remember, I take my eyes from left to right. From left to right, do I have addition or subtraction? Yes, I do. I have one subtraction problem. And 32 minus 10 is pretty simple. I can do that off the top of my head. It's 22. So the answer to example number 1 is 22. Let's move on to example number 2. Example number 2. Again, we want to start by writing PEMDAS at the top of our paper. P E M D A S. I'm circling my addition and subtraction and my multiplication and division. Now I'm going to take my eyes from left to right. Take note of any parentheses I have. None. Exponents. I'm going from left to right. Yes, I do have an exponent right at the end of my problem. I have 2 to the second power. Okay, so I'm going to rewrite my entire problem except for just this portion I'm going to solve, okay? If you're not so good with exponents, check out my video on exponent. It will really help you out and give you a good understanding of what's going on. I'm not going to go into too much detail here of how to solve this because I'm assuming you already know at this point, and if you don't, go watch that video. Okay. Rewriting, I have 12 plus 30 divided by 6 minus. So I have rewritten this entire thing except for this portion. I will not write 2 to the second power again. I will write what the answer to that is, and the answer to 2 to the second power is 4. So I'll write a 4 here. Okay. Do I have any more exponents in my problem? My new problem that I've just created, actually. No, I don't. Now, I check my new problem for multiplication or division. Does not matter which one comes first. Okay, I'm going from left to right. Okay, I have some division. It's the very first thing I've come in contact to that's either multiplication or division, so I need to solve it right now. Let's rewrite the entire problem except for 30 divided by 6. That will be written down as its answer. Okay, so that's 12. It just comes down. Plus, what's 30 divided by 6? 5. And then we have a subtraction sign over here. You just write that. And the 4 just gets rewritten. Okay. Do I have any more multiplication or division? No, I don't. So I'm done with this step. Now I'm on to the next step. Addition and subtraction. I'm working from left to right. I have 12 plus 5. 12 plus 5 is 17. So I'm going to rewrite this whole problem except for just the 12 plus 5 part will be rewritten as the new answer. So that's 17. Now, this is subtraction, bring it down. And the 4, bring it down. Okay? Do I have any more addition or subtraction? Yes, I have subtraction. Let's solve this. 17 minus 4. That's pretty easy. I can do it off the top of my head. It's 13. Write that down. Good. So, the answer to example number 2 is 13. Let's move on to example number 3. Example number 3. Let's start off with our PEMDAS in the top corner. PEMDAS. You may notice that when I write my PEMDAS, I go ahead and leave a little bit of space because I know I'm going to circle in there. Okay. Let's move from left to right. Do I have any parentheses? I do. Okay. When you have parentheses, they can be a little trickier. I tell my students that parentheses means that you have your own problem inside of these parentheses, okay? So now you can really think of not having the 45, the division sign in this parentheses or this parentheses. Let's just think about having a problem 3 to the second power times 1. That is my new problem. So now within that new problem itself, I must use the order of operations. So within that problem, I could end up doing addition and subtraction and multiplication and division. And then once all of that is done, I have to get whatever my answer is to incorporate it into the full problem. Okay? So these parentheses are really like telling you to solve this one problem first, get an answer for it, and then solve the whole thing. Okay? So, with our parentheses, let's rewrite what we have here. We have 3 squared times 1. Let's follow order of operations just on this part of it. Do I have parentheses here anywhere? No. Do I have exponents? I do. Let's solve that. What's 3 to the second power? It's 9. So that's 9 times 1 because I'm rewriting the entire problem but just solving that part. Do I have any multiplication or division? I do. What is it? It's 9 times 1, so that's just 9. I'm done. If you end up with a single digit, you don't really need to go on because there's nothing else that you can do. But do not think that this 9 means it's the answer to the entire problem because remember, we only solved this portion. So now I must take my 9 and plug it back into the original problem. So I have a 45 here divided by the 9. And really, this is just the reverse of a multiplication fact. And so we know that 45 divided by 9 is 5. So the answer to example number 3 is 5. Let's move on to example number 4. Example number 4. I'm going to start by writing my acronym for PEMDAS. Circle my A and my S and my M and my D. Okay, now from left to right, I'm going to pick out any parentheses that I have. Okay, I have 3 squared times 2. And before I go on, I do want to point out that this multiplication symbol is different than some of the others that you may be used to. This multiplication symbol is just a dot. It is not a decimal. It's higher up than a decimal would be. A decimal would be lower. But when we're dealing in math, we have a lot of variables. Variables are those letters you see a lot of times, like A, B. Well, X is a variable that we use a lot, but we also use X for multiplication. So sometimes when we're getting in more advanced math, you're going to see this dot more often, because if you had an X for multiplication, but you also have an X as a variable, you're going to be confused if the X represents multiplication or some variable. So when you're maturing in your math, you're going to see more dots, okay? So my parentheses is 3 squared times 2. I'm going to solve just that portion. Three squared is 9. I'm going to rewrite my times 2. And I get 18. Now I need to plug this 18 into my overall problem. So I have 42 minus 18 divided by 3. Remember, we really only solved the parentheses portion in our overall problem. We only plugged the answer that we got for our parentheses back into the original problem, okay? So really, we're still on the parentheses step. We need to check to see if there's any more parentheses. There are not. Now we're only on the exponent step. There are no exponents. Multiplication and division. Yes, we have 18 divided by 3. So 42. And my subtraction sign just get rewritten. 18 divided by 3 is 6. And then we just have this one subtraction problem right now. And that is 42 minus 6. And that gives us 36. So the answer to example number 4 is 36. Let's move on to example number 5. Example number 5. Let's write our acronym up top. PEMDAS. Okay. Working from left to right, do I have any parentheses? Okay, I have something a little different. These are brackets. Brackets are a little different. Brackets are used when you have a set of parentheses inside another set that you want to be parentheses. If this problem were written with another parentheses here instead of using brackets, it may be a little confusing, like where does one parentheses end and where does the other one begin? It's confusing. You might think that this parentheses mark would go with this last one, or vice versa. You might think this beginning parentheses mark went with this first ending parentheses. You may not know. So we clarify this by using something similar to parentheses like brackets. And you may find other types of brackets that look slightly different than this, that may have like a little squiggle or something, and that's fine. So we have parentheses, and it's everything from this 5 all the way down to this 4, and like these closing brackets, okay? So within that problem, I'm going to ask myself, do I have any parentheses starting from the 5? Yes, I do. I have this portion, the 8 to the second power divided by 4. So I'm going to start off by working just this portion. 8 to the second power divided by 4. Okay, so within this, do I have any parentheses? No. Do I have any exponents? I do. What's 8 times 8? 64. So you rewrite that. Divided by 4. Do I have any other exponents? No. Do I have any multiplication or division? I do. I need to solve. What's 64 divided by 4? 16. This 16 only goes inside these interior parentheses. That's the only thing that this 16 substitutes. So we're going to rewrite the whole problem with just that. And it's going to look like this. 5 plus 16 minus 2. This portion is still in parentheses. I've changed to just the regular parentheses because I no longer have two separate sets of parentheses since I simplified that interior one. Now I need to still follow all my normal order of operations. We left off with just parentheses, so we do still have parentheses in our problem. So we need to add the 5 and the 16. And that gives us 21. And then we subtract 2. And so obviously there's no multiplication or division, so we're just going to jump to the last section, which is addition and subtraction. So we're going to subtract 21 minus 2 gives us 19. So the answer to example number 5 is 19. Let's move on to our final example, example number 6. Example number 6. Let's start by writing our order of operations again. PEMDAS. Do I have any parentheses? Yes, I do. Actually, 2. Okay. I'm looking at the interior parentheses because that's what's going to be done first within my parentheses. And it's really simple, so instead of rewriting the entire thing, I'm just going to solve this portion in my head. 15 minus 13 is 2. So now I'm going to rewrite the whole problem, except the 15 minus 13 portion will be a 2. So here I go, 36. Divided by, I'm also writing my parentheses as a regular parentheses this time instead of a bracket because I'm only going to have one set. I'm not going to have two sets, which would need to be used to identify the end of one and the beginning of another. So I'm just going to write regular parentheses. 2 to the third minus 2. This 2 came from subtracting 15 minus 13. Now I'm going to close my parentheses. Now I need to solve just this interior portion because really on our overall problem we're still only on the parentheses step. When solving just this interior portion, this is going to make it so that we're actually solving a subtraction problem before we solve division. If we were to follow the order of operations for our overall problem, we would not do that if there were no parentheses here, but the parentheses make it so that you solve just this part first. So the parentheses control a lot. The parentheses may make the problem seem somewhat confusing because you will solve subtraction first. But we're only doing that because parentheses are telling us to do this portion first, okay? Now let's solve 2 to the third power minus 2. 2 to the third power is 8. I need to rewrite my subtract 2. 8 minus 2 is 6. Now I need to rewrite my entire problem, But instead of writing my parentheses portion, I'm going to write 6. So I have 36 divided by 6. 36 divided by 6 is 6. So the answer to example number 6 is 6. Thanks for watching. That's the end of this video. If you liked this video, don't forget to click like, then head over to supereasymath.com for more math tutorials, printable video notes, worksheets, and more.